presenting our touchless smart bin.
So after weeks of circuit design, failed test and significant engineering challenge that forced us to rethink how we are handling sensor signals entirely, and we finally made our touchless smart bin. So all of you would have a question, what components did we use?
So we are using Arduino Uno, IR proximity sensors, ultrasonic sensor, SG90 servo motors, op-amp, LED, NPN transistors, capacitors, standard and Zener diodes, different resistors, a 6-volt power supply, and some breadboards and jumper wires. Each of these components have a specific role in the system. At a high level, we have 3 blocks in our system. A sensing and fusion block that detects the user, a timing and processing block that controls how long the lid stays open and tracks fill level. Then there's the actuation block that does the physical work opening the lid and moving the gauge. Let us walk you through each one.
This is IR proximity sensor. We thought it would behave like every other sensor we used. Output high when it detects something and low when it does not. Like it does opposite. It is active low when it sees the person. The output drops to 0 volt. That broke our entire circuit logic. We had to start from the scratch. The solution was a circuit designed ourselves, a two transistor active low NOR gate. So how does it work? Total we have 2 sensors, one for the user detection and the second for the dog inhibit condition. So together they both convert the 2 inverted signal into one final standard output. So first of all, sensor detects a person. The first transistor pulls the trigger node high. If the bottom sensor detects something near from the ground, or when the both sensor detect something together, the second transistor overrides and holds the node low. The result, the lid will open only for the genuine user.
So opening the bin is only half the problem. How long does it stay open? We built a hardware timer using an RC circuit and the first half of an LM358 op-amp comparator. The trigger charges a 100 microfarad capacitor. The comparator watches the voltage. Above 2.5 volts, the bin opens, and below it, the lid closes.
Now let's see some other feature. An ultrasonic sensor inside the bin continuously measures the distance to the trace surface. An Arduino maps the distance 5 cm to 10 cm to the servo angle. There is no display, no number or on a screen, just physical needle that moves, analog readout. It's the kind of engineering that feels honest. The second half of the LM watches the motor supply voltage through a resistor divider. A 3.3 Zener diode holds the fixed reference. When the supply is healthy, the comparator is silent. When the supply is low, the LED turns on. One component, no firmware, a quiet warning that something needs attention.
There is one thing that does not get talked about enough in projects like this, and that is power. When a servo motor actuates, it does not draw current smoothly, it surges. To fix this, we completely isolated the power range. The 2 servos run entirely on a separate 6-volt power line. The Arduino and the other sensors run on a separate 5-volt logic supply line. The only connection between the 2 lines is a common ground rail, which gives the Arduino's PWM signals a valid reference so that the servo's current surge never touches the supply line. After that change, not a single reset. This is the top IR sensor. The bin opens only and only when this sensor is activated. This is the bottom IR sensor. Whenever this sensor is activated, the bin remains closed. It cannot open while this sensor is activated. But having perfect circuit doesn't matter if the physical mechanics fail. Translating electric signals into physical motion brought its own headaches. We had to figure out the exact mechanical linkage to lift the lid. This is the servo motor which acts as the gauge. It indicates how filled the dustbin is. It is controlled by this ultrasonic sensor, which measures the trash level in the dustbin.
Started with a problem that most people would not call an ideal engineering problem. A bin that is inconvenient to use. but we ended up designing a custom logic gate, a hardware timer, an isolated power system, and an analog readout, all just to solve one problem.
We are Vansh.
Aksh.
Jaidev, and this is our Touchless Smart Way.